This is SpaceTime Series 27, Episode 34, for broadcast on the 18th of March 2024. Coming up on SpaceTime, SpaceX's Starship almost aces its third flight test. It was the first spacecraft to reach interstellar space, but is Voyager 1's mission finally coming to an end? And astronomers get their clearest picture yet of the high-energy universe. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The world's largest and most powerful rocket, SpaceX's Starship Super Heavy, has completed a mostly successful test flight. The 122-metre tall mega rocket thundered into blue Texan skies from SpaceX's Starbase launch complex in Boca Chica on the Gulf of Mexico coast.
Go for launch.
Flight Director Ty Huntington telling the team we are go for launch. So let's listen in.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nominal.
30 seconds into flight, we are feeling the rumble. We are seeing 33 out of 33 Raptor engines ignited on the Super Heavy booster.
Booster and ship, avionics, power, and telemetry nominal. Acquisition of signal, Corpus Christi.
Continuing to get good call-outs. Our trajectory looking nominal, systems looking nominal. At this point, we've already passed through max Q, that maximum dynamic pressure, and passing supersonic, so we're now moving faster than the speed of sound. The next major milestone is going to be a hot staging maneuver, and we're going to be doing that in just about 90 seconds. To do that, we're going to shut down all but the 3 center Raptor engines on Super Heavy. That'll be our MECO, our most engines cut off, and then the clamps holding the 2 stages together are going to release. Starship's second stage will ignite its engines, the RVACs first, the sea levels right after that. The sea level engines will be splayed or just kind of pointed out at about a 15-degree angle, and so those 6 engines will push Starship off of the booster. All right, counting down now. We're going to be coming up right at around the 3-minute mark on that hot staging maneuver, and that will start carrying the ship into space. Booster will start to do its flip and then move into the boost back burn, setting it up for eventual splashdown in the Gulf of Mexico.
It was a case, well, almost of third time's the charm, as the gleaming stainless steel rocket successfully reached orbital velocity, riding on a flaming golden pillar of light. Then, right on time, the Starship upper stage successfully undertook a hot staging separation from the Super Heavy booster stage 2 minutes and 45 seconds after liftoff, continuing on its journey into space.
Stage separation. Boost back startup.
Hot staging confirmed. Boosters now making its way back, seeing 6 engines ignited on ship. Kate, we got a Starship on its way to space and a booster on the way back to the Gulf.
Oh man, I need a moment to pick my jaw up from the floor. Just stunning. First stage is currently performing
ship avionics, power, and telemetry nominal.
Good there. News informing us that the second stage, or the ship, everything looking good, nominal there. First stage is currently performing the boost back burn, expecting that to last about 1 minute. That boost back burn propels the booster back towards the coast, taking it to a landing in the waters of the Gulf of Mexico. We're only using the Super Heavy booster's 13 center engines from here on out. Those are the ones that can gimbal. In other words, they move and change direction in order to change the thrust to steer the first stage back to Earth. Everything is looking good for both the first stage, or the Super Heavy booster, as well as on the Starship, or we also refer to that as the ship. Now, the boost back burn was the first of 2 burns required to return it to Earth. The next one will be the landing burn, where all 13 center engines will initially ignite and then transition into a 3-engine burn to help slow it down. Now, just as a reminder, reminder of the Stage 1 test objectives. We're looking for controlled ascent, which we have so far. Stage separation, which, gorgeous, we cruised right through it, as well as
on a nominal trajectory.
good news there telling us that the path that Starship is on is good. Now, Starship's second stage is still firing its engines, and as you heard, following planned flight path, the ship objectives, we're looking for hot staging, again, cruised right through that. We're looking to demonstrate controlled ascent, as well as orbital insertion.
Super Heavy is performing beautifully today. It's on its return leg of the journey. Ship continuing to burn its 6 engines, the Raptor vacuum engines, the Raptor sea level engines, about 30 seconds away, just under 30 seconds away from the start of the landing burn on the booster. Grid fins rotating. Those hypersonic grid fins are guiding us through the atmosphere back towards our splashdown site. Again, we're going for a for a splashdown, a soft splashdown. So for landing burn, we're going to expect to see the 13 center engines light, rapidly bring down the booster's velocity, and then just the 3 in the center for splashdown. We're getting a few engines. And acquisition of signal. Let's see if we can get some other video of that.
However, neither Starship nor its Super Heavy booster survived the journey all the way through to their intended splashdowns.
Now, this is a test objective today. It is still something that we're attempting to learn. And to make it that far, to demonstrate the controlled re-entry up to that point is pretty darn good.
The Super Heavy core stage successfully initiated its flip maneuver and boost back burn in order to change its trajectory and speed. And that was followed a few minutes later by a landing burn above the Gulf of Mexico. However, it seems the Super Heavy failed to ignite all of its landing burn engines as planned, leading to the loss of the booster.
Ship continuing to look nominal with its ascent burn. This burn lasting about 6 minutes total, and we're expecting that this burn will end just after T+8 minutes, about a minute from now. So far, though, I mean, congrats to the team. Making it this far is farther than we've gone
Absolutely.
On Flight 2. So far, we've hit controlled ascent. We're in the middle of that right now. We demonstrated the hot staging, cruised through that. We demonstrated controlled entry of the booster. Just stopped a little short of the engine relay, but hey, that's something we can learn for the next one.
Engine cut off.
As you heard there by the call out and from the crowd behind us, Starship's 6 Raptor engines have successfully shut down. We heard a call out for nominal orbital insertion, which is incredible.
We're farther than we've ever been before. We've got a Starship not just in space, but on its coast phase into space. Just to recap where we've come, and we lifted off right on time at 8:25 a.m. We didn't have to hold at our gate at all. We had 33 out of 33 Raptor engines open up and light and get us through a nominal ascent. Another successful hot stage. All 6 engines on the ship propelling us into orbit. We did see what looked like a nominal boost back burn, and then we make it all the way to the landing burn this time. Didn't light all the engines that we expected, and we did lose the booster. We'll have to go through the data to figure out exactly what happened, obviously, so we'll be on the lookout for information about that. But a ship in space, we've got a bunch of, as we said, ambitious objectives ahead of us over the next couple of minutes and pretty much over the next hour, where we're going to we've got the ship in space. We're now going to take advantage of this and try and learn as much as possible about some of the other systems, including that first ever Raptor relight in space. So it's just going to be incredible. So what a liftoff, what a hot stage, what an amazing sight to see Starship there in outer space.
The upper Starship stage continued flying after separation, eventually entering a planned suborbital coasting phase above the planet. Now, during this maneuver, SpaceX needed to demonstrate 2 of the spacecraft's flight systems needed for vehicle qualification, namely the transfer of cryogenic fuel between tanks and the reignition of Starship's Raptor engines. Now, following these operations, Starship began re-entering the upper atmosphere, just as planned. This was about 65 minutes into the mission. They were aiming for a splashdown in the Indian Ocean about 1,000 kilometres off the West Australian coast. However, during the descent, mission managers suddenly lost contact with the spacecraft. Now, despite the loss of both craft, SpaceX insists the mission did achieve many of the key goals that were set out during the flight. This was the third test flight of the full Starship Super Heavy stack, the world's biggest and most powerful rocket. 2 previous attempts to launch the giant vehicle into orbit both failed. SpaceX was forced to issue a self-destruct order, blowing up the vehicle during its first test flight back in April last year after the upper Starship stage failed to separate from the Super Heavy stage as planned. Now, that problem involved the spacecraft simply not reaching sufficient velocity or altitude due to multiple engine failures on the Super Heavy booster. That's because of damage to the Raptor engines caused by debris thrown up by the rocket's initial thrust, blasting the launch pad to bits during liftoff. It meant the rocket never had enough power to reach its intended altitude and speed, instead entering an uncontrolled spin due to loss of thrust vector control, in the process triggering the activation of the flight termination system. The second test flight, back in November, lasted a bit longer than the first, and there was a successful stage separation. But as the Super Heavy initiated its flip maneuver and boost back burn, one of the engines suddenly exploded, apparently due to a filter blockage, which caused inadequate inlet pressure in the Raptor engine's oxidizer turbopumps. Meanwhile, the upper Starship stage continued to ascend normally for about 7 minutes until a leak in its aft section developed during a planned oxygen venting. And that triggered a combustion event which interrupted communications between the spacecraft's flight computers. That caused full engine shutdown, which then triggered the autonomous self-destruct system to initiate. The Starship Super Heavy has twice the power of the world's second most powerful rocket, NASA's SLS, or Space Launch System, which carries the Artemis Orion moon spacecraft. And Starship is playing an important role in NASA's Artemis Man-Moon program. See, a specially modified version of Starship, to be called the Human Landing System, or HLS, will be used as a sort of lunar shuttle in 2026, transporting the Artemis 3 crew and their equipment from the Orion spacecraft in cislunar orbit down to the lunar surface and back up again. So not only will SpaceX need to show that it can launch, fly and land Starship safely, they need to be able to prove they can do it multiple times, as several tanker versions of Starship will also need to be launched to refuel the HLS in Earth orbit so that it has enough fuel for its mission to the Moon, down to the surface, and then back up into cislunar orbit. And let's not forget, SpaceX's boss Elon Musk's vision goes far beyond the Moon. Musk sees Starship as a colonial transport system, ultimately replacing the Falcon 9 rocket and Dragon capsule to eventually carry humans not just to the Moon, but onto Mars and beyond. Musk fears that humans have all their eggs in the one basket, planet Earth, and he wants to establish a second lifeboat colony on another world, just in case. And considering how reminiscent the world today is of 1930s Germany, and when you add to that the added threat of today's nuclear capabilities, you really can't blame him for feeling that way. This is SpaceTime. Still to come, Voyager 1 was the first man-made spacecraft to leave the solar system and enter interstellar space, but there are now growing fears its mission may have come to an end. And a new telescope in Earth orbit is giving astronomers a clearer picture of the high-energy universe. All that and more still to come on SpaceTime. NASA's Voyager 1 spacecraft is the most distant man-made object in space. It's more than 24 billion kilometers away. However, this first spacecraft to cross into interstellar space isn't doing well, and its days seem to be numbered, as it's been sending back incoherent messages to mission managers since November, and scientists don't know why. But now, finally, the team at NASA's Jet Propulsion Laboratory in Pasadena, California, who have been in charge of the Voyager mission, may have a clue. The source of the issue appears to be with one of the 3 onboard computers, the Flight Data Subsystem. It's responsible for packaging the science and engineering data before it's sent back to Earth by the Telemetry Modulation Unit. On March 3rd, the Voyager mission team saw activity from one section of the Flight Data Subsystem that differed from the rest of the computer's unreadable data stream. The new signal still wasn't in the format used by Voyager 1 when the flight data subsystem's working properly, so initially the team still didn't know what to make of it. But an engineer with the agency's Deep Space Network, which operates the radio antennas that communicate with both Voyagers and other spacecraft traveling to the moon and beyond, was able to decode the new signal and found that it contains a readout of the entire flight data subsystem memory. Now, the flight data subsystem memory includes the spacecraft's code or instructions for what to do, as well as all variables or values used in the code that can change based on commands and spacecraft status. And it also contains science or engineering data for downlink. Now, mission managers will now compare this readout to the last one that came down just before the issue arose, and they'll look for discrepancies in the code and the variables to potentially find the source of the ongoing issue. This new signal resulted from a command sent to Voyager 1 on March the 1st. Simply called the poke, the command is meant to gently prompt the flight data subsystem to try different sequences in its software package, just in case the issue could be resolved by going round a corrupted section. Now, because Voyager 1 is more than 24 billion kilometers from the Earth, it takes 22.5 hours for a radio signal to reach the spacecraft, and of course then another 22.5 hours for the probe's response to reach the antennas of the Deep Space Network here on Earth. So, the team received the results of the command on March the 3rd. By March 7th, engineers began working to decode the data, and on March the 10th, they determined that it contained a memory readout. The team is now analysing that readout. But using that information to devise a potential solution and then put it into action will take time. Still, time's what they've got plenty of. Voyager 1 and its sibling Voyager 2 have been on their journey now for more than 40 years, ever since they were launched way back in 1977. They're both more than 130 times further away from the Earth than what the Earth is from the Sun. The two spacecraft were originally on a 4-year grand tour of the outer solar system. That was made possible by a unique alignment of the planets, which allowed the probes to use the gravity assist of each planet to literally slingshot them to the next planet. While Voyager 2 visited all 4 of the outer planets, the gas giants Jupiter and Saturn, as well as the ice giants Uranus and Neptune, Voyager 1 focused on the gas giants alone, before turning its attention to the edge of the solar system and interstellar space beyond, a realm it is now exploring. This is SpaceTime. Still to come, astronomers get a clearer picture of the high-energy universe, and New Zealand launches its 45th Electron rocket. All that and more still to come on SpaceTime. Astronomers have been given a clearer picture of the high-energy X-ray sky thanks to the first all-sky data survey release by the Rosetta telescope. The spectacular observations have allowed scientists to study new details of a supernova remnant, the dying remains of a massive star that exploded eons ago. Rosetta is a German X-ray telescope instrument fitted aboard the Russian Spectre RG spacecraft. Now, there were fears that this data might have been lost following the West's boycott of Russia following the Kremlin's invasion of Ukraine. That's because all cooperation with Moscow, other than the International Space Station, but including all other space sciences, has been suspended in the wake of the brutal Russian campaign. However, Rosetta remained operational and transmitted data back to scientists, in the process providing the largest X-ray catalogue ever published. Now, a whole swathe of scientific papers have already been released in the wake of the observations, and these include 2 led by Australian researchers Adele Goodwin and Silvia Mantovernini, both from the International Centre for Radio Astronomy Research at Curtin University. Goodwin and Mantovernini combined X-ray data from Rosetta with optical and radio data from Australian telescopes in order to get deeper insights into high-energy cosmic phenomena. Goodwin and colleagues watched a supermassive black hole destroy a star in a tidal disruption event at the centre of a galaxy some 1.3 billion light-years away. The destruction was first observed as a bright X-ray source by Rosetta, before Goodwin and colleagues used the Australia Telescope Compact Array at Narrabri in northern New South Wales to track the star's debris field ejected by the black hole over 2 years as it moved through the galaxy. These observations have been informing scientists about how stars are destroyed and how the black hole spat out the material as the star was consumed. It also gave the authors some excellent information about the central region of this distant galaxy. Meanwhile, Vanini and colleagues used eRosita's observations to study a supernova remnant within our own Milky Way galaxy. Vanini says her team used several radio surveys to confirm that the X-ray diffuse structure observed by eRosita was indeed a supernova remnant.
For my work, I'm trying to combine data at two different wavelengths to look for supernova remnants along the galactic plane. This is pretty useful because different wavelengths can give us different information on the sources. In particular, in radio bands, so using the MWA, the Martian Unlimited Array here in Australia, we are able to better identify these objects on the plane because of their structures and because the electrons lose less energy at low frequencies, so we are able to detect even the older candidates. Instead, with X-rays, we are able to have information about the composition of the object, so we can confirm what kind of sources we are looking at. And we have information about the mechanism that is involved in the emission that we detect. So we are able to say if we have, for example, accelerations of electrons.
And by looking at this, you can find out a lot about the object itself.
Yes, exactly. Combining observations from two different surveys, we are able to confirm with certainty the nature of the object. So, for example, in this particular case, the candidate we have identified was already discovered in previous surveys, but because they just had data from a single radio frequencies, they couldn't say much about it. But adding the eRosita detections, we are able to confirm that this object is actually a supernova remnant.
And the eRosita data is absolutely amazing. It's found so many hot X-ray sources throughout the galaxy and beyond that scientists, astronomers are going to be looking through this material for years.
Yes, the eRosita, the first survey of the eRosita detected more or less 900,000 of sources. That is like 25 times the number of sources that has been detected from previous X-ray surveys. And this is exciting. We're able to see so many bright X-ray sources, black holes, supernova remnants.
How fortunate it was that we were able to get this data, because it's on a Russian satellite and we weren't sure the Russians were going to cooperate because of the situation in Ukraine.
Yes, actually the telescope is owned by a Russian-German collaboration, so we are actually using the German part of the data, so we are able to see half of the X-ray sky. The other half is in the hand of the Russians, and unfortunately we can't study the data. So luckily the remnant in this particular case was in the right side of the sky. We have to say that was a bit fortunate.
So tell me about the supernova remnant you were studying. How far away is it? What do we know about the progenitor, if anything at all? What were you able to determine?
So the remnant I'm studying is G321.3 minus 3.9, and the name is composed by the galactic coordinates of the object itself. So as you can see, it is located at high latitudes from the plane, and this means that the absorption of the X-rays is less strong, and that's why we're able to see it pretty clearly. We have an estimate of the distance. It's pretty it has a lot of uncertainties. It varies between 600 and 1,000 of parsec, and this means that it's located from us at a distance of 100 million times the distance that there is between us and the Sun. We are able to determine this distance by X-rays analysis. In particular, we have determined the quantity of electrons that we have between the source and us, and so we can estimate an upper limit of this distance. Instead, with radio emissions, looking at the brightness of the source, we are able to determine a lower limit. We can't say a lot about the progenitors. There are two possibilities. So in the case of the supernova remnant, we can have a massive star or a white dwarf that can generate explosions. In the case of a massive star, it is composed of an onion-kind structures where the center is composed by iron, so it's a pretty heavy element, and the star is not able to burn it anymore. So all the outer layers of this star collapse toward the center, increasing the density of the star itself and generates the explosions. Instead, in the case of a white dwarf, it could either be in a binary system with another star or with another white dwarf, and it's accreting matter from the companion, increasing once again the density of the core and then generating the explosions. So we have these two kind of phenomenon that can happen. And the first thing to understand what is the progenitor of a supernova remnant is to check whether there is a compact object inside the shell of the source. And we don't have it in our case.
Is that part of the hope now, to get a spectra of the thing so you can work out whether it's a type 1A or a type 2?
To try to determine the classification, we usually look at the X-ray composition. So through this technique that is called spectroscopy, we look at what are the elements that compose the remnant. And to be a type 1A, a white dwarf exploding, we have to detect hydrogen absorption lines. So we have to have hydrogen in the composition of our remnant. If we don't see the lines, it's more likely to be a massive star. A type 2, yes, a type 2 supernova. Also the shape, it could be a factor. Type 1A are usually more symmetric with a circular shape. So in our case, we don't have hydrogen and the shape is pretty elliptical. I don't know if you have seen an image. So we expect to be a type 2 supernova. So we expect to be a massive star exploding.
Do we have any idea how old it is yet?
We estimated an age of 4,000 kilo-year, but it's based on the estimate of the distance that we made. So we can't be 100% sure that this is the actual age of the remnant. We need to have further observations.
What are you going to do now? Are you going to keep digging into this or start searching for other ones, or what's the plan?
So now I'm actually combining data from two different radio surveys to have a deeper image of that particular area of the sky. And so hopefully we could be able to determine what is the mechanism that is driving the emission of the remnant, and so determine the distance and the age in a more accurate way. And at the same time, we will look around the same region to see if we can detect other supernova remnants.
That's Silvia Mantavanini from the International Centre for Radio Astronomy Research at Curtin University. And this is SpaceTime. Still to come, Rocket Lab launches its 45th Electron rocket into orbit, and later in the science report, a new study shows that kids in the outer suburbs of Australia's largest cities are twice as likely to wind up getting asthma as those in inner city areas. And scientists really aren't sure why. All that and more still to come on SpaceTime. Rocket Lab has successfully launched its 45th Electron rocket, placing a new Earth observation satellite into orbit. The All Night Long mission launched from Pad B at Rocket Lab's Launch Complex 1 in New Zealand's North Island, carrying the STRI-X3 synthetic aperture radar satellite into a 561-kilometre high sun-synchronous orbit, thereby further expanding Synspective's existing satellite constellation. The launch came on the heels of its on-closer inspection launch from New Zealand just a week or so earlier. That placed the new experimental satellite into orbit, designed to pioneer new methods of space junk removal. The ADRAS-J, or Active Debris Removal by Astroscale Japan satellite, will approach and inspect a disused Japanese H-2A rocket stage, which was left behind in low Earth orbit during the launch of the GOSAT Earth Observation Satellite in 2009. The spacecraft will use its onboard cameras and sensors to assess the spent rocket stage's condition and its behavior and attitude in space. The insights gained from this mission will be vital for exploring potential techniques for safe deorbiting of similar objects in the future, as part of efforts to combat the growing challenge of space junk in orbit. Meanwhile, Rocket Lab are already preparing for their next mission. This will be a classified satellite launch for America's National Reconnaissance Office. And importantly, this will also be the first launch from Rocket Lab's new Space Launch Complex 2, located at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. There's been a long build-up to get Launch Complex 2 operational. Rocket Lab have been forced to jump through all sorts of hoops in terms of safety and engineering requirements in order to get American approval. But it's all systems go now, and that launch could be taking place in the next couple of days. We'll keep you informed. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has found that children who live in the outer suburbs of Australia's 4 largest cities are twice as likely to end up with asthma as those who live in inner city areas. The findings, reported in the journal Allergy and Clinical Immunology, are based on health data captured in the last Australian census. The data was gathered after Australians completing the 2021 census were asked for the first time to also share information about long-term health conditions in order to help researchers map patterns of chronic disease across the country. The authors don't know why kids aged between 5 and 14 who live in the outer suburbs of Sydney, Melbourne, Brisbane and Perth were more likely to develop asthma. They expected the inner city might have the most childhood asthma cases because of heavy traffic flow and air pollution. But instead, the clear pattern was one of an increasing asthma risk towards the outer suburbs, where 12% of kids suffered from childhood asthma as opposed to just 6% in the inner cities. However, it is worth pointing out that previous studies have shown a strong correlation between the risk of developing asthma and socioeconomic factors. A new study suggests that small amounts of apple cider vinegar every day may help overweight or obese people lose weight and reduce their body mass index. The findings, reported in the British Medical Journal, are based on a small study of 120 people aged between 12 and 25 that was split into either those who drank a placebo or those who drank either 5, 10 or 15 millilitres of apple cider vinegar every morning. After 12 weeks, the groups who drank the cider lost an average of around 5 to 7 kilograms, while those who drank the placebo lost less than 1 kilo. A new study has shown that the clever Australian magpie gets its smarts thanks to nurture rather than nature. The findings, reported in the Journal of the Royal Society Open Science, are based on a study designed to test whether the Australian magpie's talents were mostly inherited or something the bird brains learnt from their flock. The authors tested magpies and their fledglings' ability to learn which coloured lids food was located under, and they found very little evidence that they inherited this ability. Instead, they found that fledglings raised in larger groups passed the test in fewer trials, suggesting their cognitive abilities are impacted by the environment, that is nurture, more than their genetics, or nature. Hydroxychloroquine, the malaria drug falsely claimed to be a miracle cure for COVID-19, has now been linked to nearly 17,000 deaths in 6 countries during the pandemic. A report in the journal Biomedicine and Pharmacotherapy found that hydroxychloroquine was actually associated with an 11% increase in mortality rates. Tim Mendham from Australian Skeptics says the study found that an estimated 16,990 hydroxychloroquine-related deaths occurred in Belgium, France, Italy, Spain, Turkey and the United States. He says the findings clearly illustrate the hazards of drug repurposing with low-level evidence.
Hydroxychloroquine is a malarial drug, and a lot of people were claiming it was good for treating, curing COVID during the pandemic. Mainly those who, ironically, people who were initially doubtful that COVID even existed, and then suddenly they were offering up these miracle cures. Apart from all the ivermectin, whose effectiveness was completely overblown, this hydroxychloroquine was put forward as a potential saviour. This study that came out recently looked at the effect of people who had taken hydroxychloroquine across 6 countries: Belgium, France, Italy, Spain, Turkey and the United States. And they found close to 17,000 cases where it looked like there had been a negative impact of taking hydroxychloroquine to the fact that they died. Okay, it was published in a recent issue of a journal called Biomedicine and Pharmacotherapy, and it's associated with about 11% increase in mortality rate. Actually, 16,990 deaths related to people taking it. They reckon this showed the hazard of the drug that was portrayed as being a safe alternative to established COVID vaccines that they were saying, that the proponents were saying were kill you. In other words, their safe alternative was actually had the potential to kill people.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.